Welcome to Haunted Talks, the official podcast of The Haunted Walk, offering thematic walking tours in Kingston, Ottawa, and Toronto, Ontario. My name is Jim Dean. I am the creative director of the company, and we really appreciate you joining us for today's episode, and hope you're having a wonderful summer. Perhaps the two most compelling questions in human history are, what happens to us when we die? A question we have engaged in many different ways on this podcast, and of course on our tours. And, are we alone in the universe? And that's the question we will be exploring today. All across the world, there are giant radio telescopes listening for sounds from outer space. No matter where these telescopes are pointed, they always hear the same thing, a kind of static, known as the cosmic microwave background, or CMB. The CMB is readily believed by the scientific community to be a leftover and the best evidence of the Big Bang. On August 15th, 1977, the University of Ohio's Big Ear Radio Telescope recorded something in addition to the usual sounds from space, which remains to this day the strongest potential alien radio transmission ever detected. Before we get to that story, I did want to let you know that our full slate of summer tours are now running in Kingston, Ottawa, and Toronto. In addition to our downtown tours in each of those cities, we also have our special Haunted Walk experiences taking place at locations such as Fort Henry, Upper Canada Village, the Mackenzie King Estate, as well as Black Creek Pioneer Village, which featured prominently in our last episode, Tales from the Tours, where a number of our tour guides explained some of the unusual things that happened at Black Creek last October. To give you a little update on that, our very first night back, several of our guests and one of our tour guides had another sort of strange encounter in the manse there. So Black Creek definitely seems to have a few surprises for us this summer as well. Information about all our different tours can be found on our website, hauntedwalk.com, and you can of course also follow us social media-wise on Facebook, Twitter, Instagram, and Snapchat. The question if intelligent life exists elsewhere in the universe is a big one. Even setting aside cultural or religious concerns, it's primarily such a big question because the universe is so big. For some, it can become overwhelming even to consider. Our galaxy alone, the Milky Way, has around 100 billion stars, 100 billion. In order to try to put this in human terms, imagine every time you breathe out, over the course of your life, you create one star. Every single breath, all day, every day, you are creating stars your entire life, with every breath. The average person takes around 672 million breaths in their lifetime, if you live to be about 80. That means it would take around 150 lifetimes of you breathing in and out to equal the number of stars in our galaxy. And there are trillions of galaxies in our universe, each in turn with their own billions of stars. What are the odds that at least one of those almost infinite number of stars has a planet in orbit around it that contains alien life? SETI, or the Search for Extraterrestrial Intelligence by Radio Telescope, began in 1960, when astronomer Frank Drake used an 85-foot radio telescope in Green Bank, West Virginia, to scan two sun-like stars for signs of intelligent life. If that name sounds familiar, that might be because he is also somewhat famous for developing the Drake equation, which attempts to determine the probability of extraterrestrial life in our galaxy, and in particular, alien civilizations that would have the capacity capable of sending a powerful enough signal to reach us. Quoting Frank Drake, As I was planning one of the first SETI meetings, I realized a few days ahead of time we needed an agenda. So I wrote down all the things you needed to know to predict how hard it's going to be to detect extraterrestrial life. And looking at them, it became pretty evident that if you multiplied all these together, you got a number, N, which is the number of detectable civilizations in our galaxy. This was the aim of the radio search, and not to search for primordial or primitive life forms. In looking at the Drake equation, there are a number of questions or probability sets to be answered. How many stars are born or formed each year in the Milky Way? What fraction of those stars would have planets? Of those planets, how many of them are likely to be habitable, or in what they call the Goldilocks zone, not too hot, not too cold, but just right for life? Of those habitable planets, how many will go on to develop life? How many will go on to develop intelligent life or a civilization? And how many of those civilizations will go on to develop the technology necessary to send the signals of their existence out into space? And finally, what length of time can those civilizations be transmitting a signal? Civilizations change, they rise and fall. How long could a signal be maintained? The Drake equation, then, is not about finding a single answer, but rather examining how changes to the variables change the overall likelihood of us receiving a message sent from our distant universal cousins. The numbers you put into the formula will determine the numbers you get out, and the formula has been used to show both the possibility we are alone in the universe, or that we are in fact just one of millions of civilizations within our own galaxy. Recently, a team of astronomers from the University of California and the University of Hawaii used the Kepler Space Telescope to survey 42,000 sun-like stars, looking for planets that fall in this Goldilocks zone, where it's not too hot, not too cold, and just the right size where life could evolve. In their report, they wrote, "We found that 22% of the sun-like stars harbored Earth-sized planets orbiting in habitable zones. The nearest such planet may be within 12 light-years, relatively close in an astronomical sense." Andrew Howard, one of the study's co-authors, enthused at a recent news conference that their 22% figure means that, with about 100 billion stars in our galaxy, that's about 22 billion such habitable planets. That's a few Earth-sized planets for every human being on the planet Earth. But perhaps we're getting too far ahead of ourselves. Back to the 1970s, many radio astronomers conducted searches using existing antennas and receivers. Some of the efforts employing improved technology are continuing to present day. How Big Ear and other radio telescopes work can be thought of by imagining yourself standing outside, somewhere where you have a reasonably unobstructed view of the entire sky. Now imagine you hold up a drinking straw to your eye, so you're kind of looking through the straw into the sky. Suddenly, the vast sky becomes reduced to a very small point, and this is the challenge for SETI. Because space is so vast around us in every direction, there is almost unlimited ground to try to cover, and you can only go through a small bit of the sky at a time. Generally, the strategy has been to make educated guesses about areas where there's an increased likelihood of possible ET life, and then survey those areas quickly with the radio telescopes, looking for anything that might cause you to double back and give increased scrutiny if anything is discovered. On August 5th, 1977, at 10:16 Eastern Time, the Big Ear most certainly heard something, while pointed towards a group of stars roughly in the direction of the constellation of Sagittarius, the Archer. With SETI projects, as much of it is volunteer-based, and the amount of data being gathered is pretty big, it's not the case that there was someone there listening with earphones to the telescope 24/7. In fact, there was no way to record the audio coming out of the telescope at all. Rather, the bulk data was printed out and then collected and reviewed later to try to make the process as efficient as possible. Again, the concept being that if something is discovered in the brief initial survey, an additional study can be used to confirm and further the research. It was a few days later that study volunteer and Ohio State faculty member Jerry R. Amon was poring over the printouts when he came across the signal, which peaked at around 30 times the intensity of the normal background noise, or the CMB. The signal was recorded for exactly 72 seconds, which is an important number. Big Ear and many other radio telescopes have relied on the rotation of the Earth to scan across the sky. Given the speed of the Earth's rotation and the spatial width, or how big the telescope's observation window is, or the end of the straw, the Big Ear could observe any given point in space for just 72 seconds. Therefore, a continuous extraterrestrial signal would be expected to register exactly that length, and the recorded intensity of such a signal would display a gradual increase from the first 36 seconds, peaking at the center of the observation window, and then gradually decreasing. All of these characteristics were present in what is now known as the WOW signal. When Jerry Amon was going through the printouts and discovered the signal, with no one else to talk to, he simply wrote in big red letters, "Wow." And since that time, that is how the signal has been referred to. So after Jerry made this rather startling discovery in the printouts, the SETI protocols kicked in. Once the signal is recorded, the whole game is to try to duplicate it. Can the signal be received again by Big Ear, other radio telescopes? Can it be repeated? Can the signal be found again? And Amon spends the next several months using the Big Ear, searching for a reoccurrence of the signal. He was not able to find the signal again, nor has anyone else who has searched for it. Possible origins for the signal include extraterrestrial life, and this is because the power of the signal, 30 times the CMB, combined with its frequency and narrow bandwidth, make it very unlikely it was a natural occurring phenomena, or somehow that it was from Earth. Though it is fair to say there's a lot about the universe we do not know. It's certainly possible that some kind of natural phenomena we have not observed before, and therefore have no frame of reference to understand it. Perhaps we're just not knowing what we're looking at, though extensive time has been spent on that area of space, and I think we would have to conclude if it is a natural phenomena, it is one that does not occur very frequently, at least in human terms, as it has not been observed again in 35 years. Interestingly, it also did come from a region of space with relatively few stars, and by extension we would assume relatively few planets, which could raise the question of the likelihood of it being a transmission from an alien civilization, at least a planetary-based alien civilization. Some have suggested that the signal could be the result of an object in orbit, like a satellite or a high-altitude plane, something else moving past or through the observation area, or the end of the straw of the telescope. The difficulty with that theory is that anything in Earth's orbit, due to how close it is to the radio telescope in comparison to something as far away as Sagittarius, would move past and through that 72-second observation window much faster than that. Also, an additional search was done at the time the signal was found, and no objects were discovered to be near the telescope at that time it was listening. As I've been researching this story, there have been two potential major developments that I would like to bring you up to speed on. The first comes from an article from Discovery Magazine by John Wentz, published June 8th, and the headline is, "Aliens, Comets, or Crap? What's going on with the WOW signal?" And reading a few passages from his article, Antonio Paris, an astronomy professor at St. Petersburg College in Florida, thinks he has the solution to the WOW signal. Two comets passed by that region of the sky in 1977, according to his hypothesis. And this year, those comets passed by again. That created a chance to test his theory. His research was accepted for publication in the Journal of Washington Academy of Science. Paris, who along with his teaching duties runs the Center for Planetary Science in the UFO Hunting Aerial Phenomena Institute, proposed the hypothesis last year. Jerry Amen, who you recall is the individual who discovered the signal, scrutinized their original proposal and didn't believe it was likely to be comets. And quoting him, "I received a copy of their article from the Journal of the Washington Academy of Sciences, and I studied it carefully," Amen said in an interview at the time. "I've concluded that neither of the two comets could explain the WOW signal, and colleagues of mine at the observatory have also concluded the same things." Chris Lintott, a professor of astrophysics at Oxford University, isn't buying any of the explanation. The signal isn't bright enough or rapid enough to be a good fit for the WOW signal. The mythology itself is flawed. While staring at the region of sky, he says there could have been about 5 minutes worth of signals if they were in fact comets, but it only comes in intermittent bursts. And if they were comets, he says, we could expect to see WOW signals all the time, as we know where a great many comets are, rather than just once in 1977 and then once again in 2017. Then there's the choice of journals. In his words, it's not somewhere where astronomers publish. I don't know what the WOW signal was. It's very hard to study something that has only been seen once, he says. For his part, Amen remains relatively agnostic on the original signal, while wanting to believe the extraterrestrial cause. He acknowledges that limits to the equipment at the time led to a sort of dead end of the mystery. It's an intriguing possibility, he says, that it's a signal from extraterrestrial life. But it's also one that I've had to declare that I can't prove that it is, or prove that it isn't. There's an interesting moment here where we see the collision between science, maybe pop science, as this study by Antonio Paris was crowdfunded, which perhaps leads to some biases, versus kind of the hard academics of someone like an Oxford professor. I will say it is interesting, if you Google the WOW signal today, many of the top pages that come up will be WOW signal explained, mystery is solved, things of that nature. But it doesn't seem like a real in-depth look has been given at the research. Now, just within the past 10 days or so, another major story has broken, and that's because astronomers were detecting some strange signals coming from a red dwarf star. And I'll read here from Mike Wall's article on space.com. On May 12th, the 1,000-foot wide, or 305 meters, Arecibo radio telescope in Puerto Rico, which is often used in movies, so if you've ever seen someone at a radio telescope, good chance they were there. On May 12th, it detected some very peculiar signals, apparently emanating from Ross 128, a red dwarf star that lies just 11 light years from Earth. So again, very close in space terms. The signals consisted of broadband, quasi-periodic, non-polarized pulses with very strong dispersion-like features, said Abel Mendez, director of the Planetary Habitability Laboratory at the University of Puerto Rico. He continued that, "We believe the signals are not local radio frequency interferences, or RFI, since they are unique to Ross 128, and observations of other stars immediately before and after did not show anything similar." Three leading explanations for the signals, Mendez wrote, are a solar flare-like emission from Ross 128. I think that would be similar to kind of the natural phenomena that was discussed with the WOW signal. Emissions from some other object in the same field of view, so something crossing the observation window of the telescope, or some sort of burst coming from a satellite orbiting high above Earth. Each of these hypotheses has its issues, he says. For example, he said solar flares of the type that could be responsible generally occur at lower frequencies. In addition, Mendez wrote, there aren't a lot of other objects in the Ross 218 field of view, and we have never seen satellites emit bursts like this before. But if you're getting the urge to invoke ET, the author writes, temper it because the recurrent alien hypothesis is at the bottom of many other better explanations. So I was expecting to end this podcast leaving that question out there. Could Ross 128 be something else like the WOW signal? Something that's difficult to explain, but certainly seems to have been recorded, and these radio waves have traveled through space somehow to us. But the developments continued, but just a few days ago, Mendez released a report on their analysis so far, which came to a rather strong conclusion, and I'll read that to you. After a careful analysis of the observations we performed last Sunday from the Arecibo Observatory, together with SETI Berkeley using the Green Bank Telescope and the SETI Institute's Alien Telescope Array, we are now confident about the source of the signal. The best explanation is that the signals are transmissions from one or more geostationary satellites. This explains why the signals were within the satellite's frequencies and only appeared and persisted for Ross 128. This star is close to the celestial equator, where many geostationary satellites are located. This fact, though, does not yet explain the strong dispersion-like features of the signal. However, it is possible that multiple reflections cause these distortions, but we'll need more time to explore this and other possibilities. So it seems that in this case they have discovered where the star is in the sky compared with the usual orbit or non-orbit of geostationary satellites is the culprit here that caused these weird signals. I know some people get disappointed when mysteries like this seem to get solved, but I find it all the more fascinating to those cases, like the WOW signal, where there is still no solid answer to the question, are aliens trying to communicate with us? So this summer, as perhaps you're sitting around a campfire on a beautifully starry evening, pause for a moment, look up, and consider the vastness of space. And using the Drake equation, maybe run your own simulation. How many stars are there? How many of those stars might have planets? How many of those stars have planets that could sustain life? What are the odds that life begins and grows to a civilization that is capable of sending us a signal? Is it possible there is just one? Because if there is, we are not alone. A big thank you to Michelle Dennis, our audio engineer, and to Kevin MacLeod at Incompetech.com for the additional music. If you've enjoyed this episode and some of our others, all we ask is that you tell one of your friends about Haunted Talks. Information about our tours can always be found on our website, hauntedwalk.com, as well as you can follow us on Facebook, Twitter, Instagram, and Snapchat, all at Haunted Walk, to see some of the other things we get up to. Recently, one of our tour guides in Ottawa, Louis Labelle, has written a couple blog posts for us about his time being a tour guide at the Vimy Memorial in France, and he shared with us some of his exploration of the ghost stories around Vimy, and also a bit what it was like to give a tour for several members of the royal family. So thanks, Louis, for writing those blogs. Very entertaining, worth checking out. Information about all our different tours can be found on our website, hauntedwalk.com, and you can of course also follow us social media wise on Facebook, Twitter, Instagram, and Snapchat. Until we meet again, sweet dreams.